Hey, good afternoon, everyone. I'm really pleased to be here. Thanks for the invitation, Brian. So today I'm going to be actually following on from Amanda's presentation, and I think it's quite relevant to what I'm going to be talking about. It's green infrastructure for water resources protection. This is a 25-year study that I had the pleasure of being a part of for about a decade, starting my previous position at the Environmental Protection Agency and continuing in Grand Valley. And really looking at successes and challenges in creating what we call spongy development. So we're going to be looking at the issue of stormwater here. And this picture, right, nothing is amiss. I would argue that that is not the case at all. This is a really stark example of what we call urban stream syndrome, right? So we see a severely degraded stream here. The habitat is poor water quality, and this is really a function of that urban landscape, right? So that urban landscape and everything that comes with it often leads to streams such as this that are degraded in terms of their water quality, their physical function, and their ecological function. So one of the most, I would say, prevalent or visible impacts of urbanization and urban development is flooding. So this is a picture a lot of you might recognize. This is the Grand River, downtown Grand Rapids, 2018 flooding. And what we see is that as we replace forests, even agricultural lands, from soft landscapes to what I call hardscapes, we end up with flood-prone environments, right? So as we transition from one landscape to another type of landscape, we often get effects such as these. And this is especially critical when we think about increasing storm frequencies and magnitudes of these storms, right? So we're more flood prone as we develop more in the context of climate change. So the last point I want to bring, I love this image. This is an image from VEERS, which is a NASA satellite, and it's showing the extent of human development using their nighttime light sensor. So what we're seeing is basically how humans touch the landscape in the entire United States here. So my point being is, with this extent of human development, those problems I just discussed in the context of urban streams, their quality and the flooding issues, they're not unique, right? Especially in the central and eastern United States, right? There's widespread human impacts. So from nothing is amiss to what's a potential solution, right? So what I'm going to talk about now is a long-term monitoring project where we looked at these issues over 25 years to see if we could bend the curve. And really we're inspired by this concept called sponge cities. So Amanda's slides, I think, were really relevant in terms of the value of wetlands. And this is a picture from Bangkok, Thailand. And so Southeast Asia and East Asia in particular have had these efforts to create these sponge cities. So China has piloted programs like this in 30 of their cities, including mega cities like Beijing and Shanghai. And it's really in the juxtaposition of the urban environment, creating these, I would say, wetland oases. And the primary goal here is to retain floodwaters, right? But there's also some co-benefits. Notice how this landscape is designed with people in mind anyway, right? The first goal is flood protection. But we can see that residents can recreate, visitors can recreate on this wetland, right? So there's trails, there's habitat, there's native plants, right? So there's a lot of co-benefits that can be designed into creating these sponge-like efforts. But they're also huge infrastructure projects, right? So what we're going to be looking at and talking about today is a bit more modest on the green infrastructure scale, but still very important. So some of you might recognize some of these landscapes here, and they're a lot smaller. They're plot scale, single family home scale, right? Parking lot scale. And this is classic green infrastructure. So on the left we have infiltration trenches. In the middle, on the bottom, we have a dry vegetated swale. And on the right, we have bioretention ponds, also sometimes known as rain gardens, that are planted with native grasses, right? And so what these do, really the same thing. The whole idea is to keep that water in place, let it sink into the soil, and ultimately let it infiltrate and percolate into groundwater, right? So Their whole goal is, rather than moving water as quickly away from streets as possible, as quickly away from buildings as possible, to hold it in place and to recharge an aquifer, right? Something like that, rather than moving water quickly away from the landscape, which often exacerbates floods. So what I'm going to describe very briefly are some scientific results from a long-term study that I was a part of. And this is called the Clarksburg Integrated Monitoring Partnership. Started in 2001, and it's still going. It's led by the U.S. Geological Survey in partnership with Montgomery County, Maryland, which you see on the map on the right, Clarksburg over there. And I participated in this as a postdoctoral fellow at the EPA's Office of Research and Development, and I'm still involved in this project today. And so it was really inspired by development pressure in ex-urban Washington, D.C. So this map on the right is basically showing a timeline of urbanization in the D.C. metro area. The darker colors indicate more recent urbanization. So in the whiter area, we're looking at the D.C. core, and as we get deeper pinks and reds, that's newer development. So we can see the expansion of these urban areas in space, right? And at the same time, we lose forest and agricultural land to this suburbanization. And ultimately, what spurred this project is the realization through consistent monitoring that there's declining stream health in the areas, especially where forest was replaced with suburban developments, right? So I'm going to talk about the values behind Montgomery County, Maryland, and kind of what led to this project via these Montgomery County Special Protection Areas. So Montgomery County recognized the issue related to development in the county, especially their loss of forests. So what the county planners decided to do was implement stringent water resources protection in new developments, right? So they recognized the value of their natural water resources, so their rivers and their wetlands, right? They have intrinsic ecological value, recreational value, and they support clean drinking water, right, as natural filters. So Montgomery County decided to actually place the burden on developers to limit impervious surfaces, build stormwater control measures, and buffer natural areas with conservation easements and parks. So what I'm really going to focus on today is kind of the distinction and the synchronization, if you will, of the limiting impervious surfaces and where they are built, implementing stormwater control measures, i.e. green infrastructure. So we can think about this on that development timeline, and our kind of, I would say, first phase of dealing with stormwater in the United States is something called gray infrastructure, where we have centralized stormwater management. Basically a few large stormwater management practices, often concrete detention basins. They're typically located really close to streams. So the idea here is moving water away from streets, from parking lots, from buildings as quickly as possible, retaining that water in a detention basin, and then releasing it to a stream. We can contrast that with kind of what I would call modern stormwater management practices or green infrastructure. The idea here is to create a sponge on the landscape, right? So distributed stormwater management has many smaller practices. We can see those green dots on the right, and they're using soils and plants to really soak up water, right? So we have a lot of these smaller practices, typically located in people's front yards, right? Or in a community green space, right? So they're really distributed on the landscape, and again, they're soaking up water in place. And the last piece of this that I think is really important is that this was an adaptive management approach. The idea being scientists, contractors, and the local government, the county government, all work together on this project to assess a problem, right? So the problem is here we have declining stream health, we have flooding, and this is a result of urbanization, right? So we design and implement strategies to solve this problem, and the key is we monitor with data and we evaluate that data, and then we rework the strategy if something's not working, right? So this adaptive management approach was really possible because of the long development timelines here. So I'm going to introduce 5 different watersheds to you, but the key here is some watersheds started their development process earlier, some later, and we use the lessons learned from earlier developments to inform later developments. Ultimately, we see increasing impervious surfaces regardless of the development, but we can sort of limit the impact on the water resources by using this adaptive management approach. So 5 watersheds here. What you need to know about the details is this is what we call a before and after control impact experiment. So we can compare things like different stormwater management practices in these 1, 2, 3 distributed treatment watersheds in terms of the impervious surfaces they have, in terms of the types of homes they have, and in terms of the type of stormwater control measures or green infrastructure they're implementing, right? We can compare those with an urban control, I would call our classic stormwater management, with centralized stormwater management practices and big box stores, so a lot of impervious surfaces. And finally, there's a forest control here. What's notable about the forest control is that's our gold standard, right? We want the landscape to be like a forest, right? We want the stream inside this watershed, inside all of these watersheds, to behave like the forested control in a natural, what we call pre-development state. So we're trying to, say, bend the curve of development towards at least our stream health being more like a forested control and less like our classic stormwater management. So just to show you what this looks like, in Montgomery County, in these watersheds, typically they have row crop agriculture, and then there's a period of construction where there's land grading and sediment control, and then finally established suburban developments with distributed stormwater management, i.e. those bioretentions and single-family homes and things like that. So we can see from the aerial imagery starting in 2002 to 2018 what something like this looks like. And you know, it's science, right? So you got to measure everything and you got to measure it often. So depending on our endpoints, what we're interested in the stream, so hydrology, the groundwater, flow attenuation of these stormwater practices, water quality, human health, we're measuring it all on varying timelines depending on what's relevant for that specific measure. Not shown here is also the fact that we're actually measuring the amount of insects in the stream as well. That's really important because they're indicators, sentinels of the health of those streams. And so what I'm going to do is just provide you with one pure success and then some successes and challenges. So when we look at comparing these development types and stormwater management measures, the green infrastructure, they're really good at reducing runoff volumes and peak flows. It makes sense based on how they're designed and how they work. The idea here is the green infrastructure is soaking up the rainfall, particularly when we have low or moderate rain events. It's acting like a forest. So there's 3 numbers here at the bottom. Basically, this is the amount of rainfall that's required for runoff to begin. The higher the number, the better. So in a forested watershed, we need about 0.8 of an inch, so 17 millimeters of rainfall for runoff to begin to eventually enter the stream. In those distributed treatments where we have the green infrastructure, they're basically reaching close to the levels of forested development. That's really good, and it's a really challenging thing to do for suburban development to act like a forest from a hydrological perspective. So we thought that was a great success. And we can compare that to our classic stormwater management, which performs much poorly. There's just a lot of runoff at any small rain event. Now into the successes and challenges. Water quality. We've had a great precursor in water quality presentation. And I want to just speak about 2 specific aspects. So one thing is nitrate. So nitrate is related to fertilizer applications. And what we see in the success is that concentrations of nitrate declined in groundwater and surface water after the implementation of these stormwater control measures. But when we're building in previous agricultural land, we have this thing called legacy nutrients. So there's nutrients that are still bound up in the soil, and they persist for a long time, which is a big challenge in nutrient reduction criteria. So we do have reductions in the amount of nitrate in our water quality, but it's difficult to reach the levels of a forested watershed, at least in this landscape context. The next one I want to talk about is specific conductance. This is basically an indication of the ions, what dissolved substances are in the water, simply put. It's typically associated with road salts, which is a big problem in the Northeast and Midwest United States. So we have rising specific conductance in all of these green infrastructure watersheds. However, they do have less specific conductance than the urban control watershed, but they can't reach the levels of the forest. So the take-home message here is more work needs to be done from the water quality perspective. The last one I'm going to talk about is protecting biota. So I mentioned these insects earlier. They're really important sentinels for the health, ecological health of streams. We call them benthic macroinvertebrates. So what we find here is these timelines of measuring the communities from forested down to the urban control. We have these gray boxes are the construction periods. Construction really hurts these, right? So when we have a construction on a landscape, that grading, their health declines, and it doesn't really recover even after we implement the green infrastructure. So this is a big problem that we still need to work on. Ultimately though, again, the urban control has the worst, I'd say the worst ecology. That's one way to think of it. So, some take-home messages here. We did find some great success, especially in the hydrological perspective of green infrastructure. So fewer impervious surfaces plus distributed stormwater practices, protected stream health in the broadest sense. But really there's still the need to control pollution sources, right? Fertilizers and road salts. So we think about things like native plantings. Replacing lawns is a huge thing we can do to improve this. And then finally, adaptive management. So I only touched on it at the beginning, but one thing I'd like to note is that process of everyone at the table, the scientists, the developers, and the local government, really led to improved outcomes. Later stage developments ultimately fared better than their precursors, the early implementations of green infrastructure. So with that, I'd just like to make a few quick acknowledgments. My colleagues at the EPA, the USGS, and of course Montgomery County, Maryland, and we do have a paper that you can refer to that's basically in-depth discussion of everything we found monitoring this for 25 years. Thank you.
So thanks everyone. We're a little bit pressed for time right now. I apologize for that. We're planning on maybe having 5-10 minutes for Q&A, but we have our keynote speaker coming at 5. And so if you would like to ask questions, engage in conversation with Sean, Amanda, or Raz, I'd be happy to meet and converse over coffee and while we wait for the next speaker. Thanks everyone.